Yeah, so I'm impatient and I pulled the back off of the controller enclosure, which turns out to have the entire controller in it. That's what this box is. Monitor. This is actually interesting. It's a line conditioner. So I think it's not even a converter, just a line conditioner. 1 AC condition 1. So I think this is just to try and keep noise out of the controller. They probably had problems with it resetting or some shit. But this can be put in 120 volt mode. So I'm gonna just pull this off and try and run it off a cut up IEC connector. We'll see what happens. All right, so I've just stubbed a cut up IEC power cord onto here. You can see it's nicely labeled. You can see here that there's an arrow there and it's set to, oops. Voltage indicator set to 120. So you can also see these seem to be the encoder connectors. I'm not too sure what these are, these two big connectors down here. It looks like there's actually a fourth connector. And then these, I believe, are limit switches and so forth. It actually looks like this is a big disconnectable thing. This is like a breakout thing. Anyways, yeah, so that's monitor part number, controller. So let's plug it in and see if it explodes. This should let us assess the controller and a bunch of other stuff. So this moves. So that makes me happy. So let's see if I can't get it to look up further. Anyways, so apparently the power was interrupted. And the monitor is freaking out a little bit, but so here's the question now is how do I, so it's freaking out because it was unplugged and I guess the NVRAM is gone. Hasn't been powered in a couple of years. So the problem I'm having is, you can see the flickering here. It looks like the horizontal sweep is having a nervous breakdown. So this appears to be almost like a calculator. That's kind of cool. So if I go over here and, so this is the jog dial and so forth. There's Z. Spindle off. So this is obviously our spindle control. Yeah, that's annoying. I'll have to see if I can figure out what's going on with my horizontal sweep having a nervous breakdown. I think this says relay external no voltage detected or something like that. So it appears that the controller works. It's freaking out because it's not finding any of the line voltages, which is unsurprising. So anyways, it's a thing. Oh hey. There's something beating against something else in there. Anyways, things. So this might look familiar. Obviously we've got this weird dithering issue. My assumption is that the power supply for the horizontal sweep may have a dried out cap and we're getting like 60 hertz on it or something like that. So the documentation for the controller, this is actually the entire controller, includes power supply rail locations and test point information, shit like that. So I'm going to go in there and we'll have a poke and see what I can see. The other thing I don't know if it'll come through, is this thing makes a horrible transformer squealing noise. Ugh. So here, this must be I/O, because we just have a. This is just an utter boatload of what looks to be contact closure inputs and relay outputs. It wouldn't surprise me if these are optos. But I think this is your, I strongly suspect this is basically all the DIO. It's a whole crapload of read relays. So this obviously must be the encoder board. We've got twisted pairs coming in. I believe, well, hang on, let me open the manual. Okay, I've got the manual up. So we have power supply board, SE board, quote, analog component board, unquote, interface board, processor board, display board, and then I think the keyboard board is somewhere up in there that I can't really get to. It actually, so this, I'm not sure. Oh, that's cool. Oh wow, look at that. So, this is obviously all of our VFDs, but look at, isn't that design really, hang on, this so you can see it better. Isn't that design neat, how the VFDs are free floating so this board can come out without having to have any other interference? So I would assume on this board we have just high voltage drivers. There may be some other logic on there. You can see the VFDs more closely. If we look down in here, that's presumably the keyboard board, because it yeah, it looks like all the buttons connect to that. There's like membranes on here. There's a bunch of little connectors down in there. This is really classic early computer layout. There's barely any 45 degrees. There's actually, I was surprised there's two of them right there that are almost certainly manual because their angles are different. You can see how the two angles are different, but everything else is rectilinear except in very certain areas where they just had to go in there and do it manually. So this is probably an auto-routed board. You can see all the same layout. This is fairly interesting. A lot of the through-hole parts are considerably floated up, and you can also see there's a couple cases where they have wire jumper bridges. I think they may be both test points and jumpers, because you can see there's no reason there need to be a jumper there. This is probably a bus bar. So this is, it functions both as a circuit board support and connection. You can see the leads are kind of staggered, one on this side, one on that side. It's possible there's actually two connections in here, but it's basically copper sheets that are punched out, and then the pins are, and then in this situation there'd be an insulation layer between them. So that would let them distribute power all the way up the board, and this is, obviously going to be very heavy metal, so they don't need to worry about, RD, resistance losses. I have to align it with the guides. There's one end and there's the other. So it just goes like that. So this next board, this is the processor board. It's the TMS 9900. So here is our processor. Actually, it's a TMS 9995, it looks like. So there's obviously our main processor. These are program memory, or firmware, and then I bet these are probably SRAM. Got a couple caps on here. These old electrolytic axial caps. You can see they've nail polished over these to try and prevent them from being erasable, because these are UV erasable EEPROMs. They've also got stickers on most of them. I think the one on this one might have just fallen off. I can see glue remnants on it. And we have another one of these bus bars slash stiffeners. This is so very, very 80s. I think this thing was produced in like 1983 or so. So this is the, what do they call this? The interface board. So one thing of note is there's, oh no, that's just a brace. I thought there might have been a shielding panel there. So here is another EEPROM TMS 9927, more DI logic. A whole lot of these parts with stickers on them that say 1.95. With a lot of 7400 series logic. Not much else. Kind of boring. It's interesting that a lot of these have little red paint marks on them. I wonder if they've been manually tested. We have another EEPROM that might run this or something along those lines. So then this is labeled the analog board, but I'm not totally certain what's there, because I'm actually not sure if this thing has encoders or like synchro resolvers or something weird. Sometimes let me go like this. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. That way I can get the connectors in the right place. One thing you might note is they've got this very large, these interesting connectors. You can see these are signal connectors, and then there's this big heavy spade terminal or something, some sort for the ground. The other thing is these are all twisted pair, which is really common for encoders on big equipment because you're so much more resilient to interference. So they use, it's all differential signaling, which doesn't surprise me in the least. What are you stuck on? Oh, just a little ejector. So this is quite interesting. So here we have a genuinely large amount of analog componentry. So we've obviously got just utter boatloads of resistors. These are all LM339, which, if I remember correctly, is a comparator. You can see here we actually have two separate bus bars. So maybe those other bus bars are in fact single. These front end components up here towards the front are RCA 4157 dB. I don't know what that is exactly. We've got all of these parts. These may be series inductors or something like that. There's actually a bunch of caps over here. I'm not too sure what this fourth input is down here. I mean, obviously we have X, Y, and Z encoders here, but there's a fourth connector, and I don't know exactly where it goes. That may be the actually, now that I think about it, that could be the manual control input. Like, it has knobs and joysticks and stuff, so that could be what that is. This is fairly interesting. It's a big, either an inductor or like a high precision resistor or something. We've got epoxy blob tantalums, but that's kind of interesting. They've got glue underneath it. I don't know why. Maybe to hold the legs in place a little bit, but it's still a little wobbly. Then we have these things, these big white boxes, well, small white boxes, which have each one has, it appears, 3 leads. So I'm not entirely certain what the devil those are. They could be inductors of some sort and some SERDIC parts down here. Yeah, I'd assume from all of these LM339s that this is like some weird. These may be like resolvers rather than encoders. Just kind of unusual. One little or 2 little metal can transistors, or I guess they could be op amps, or not op amps, ICs like voltage references or something like that. It is a 3-pin device though, so you're somewhat limited in what they could do in that package. Anyways. So you can see just down in the bottom is just a where did my flashlight go? Like this. So down in the bottom there is just connectors and power distribution and stuff like that. Nothing else. Just a backplane basically. So one thing the instructions mention a number of times is the battery, and I haven't found it, so I think it might actually be in here. It certainly doesn't seem to be in the happiest condition. See if I can figure out a way to get that off. It's probably in horrible shape. So there's actually a O-ring gasketed metal cap, and then a plastic retention spring, and then the actual battery is... Oh. Wow, really? It's literally just an Energizer AA. That seems to be about it. Is there anything else in there? Inside, I think there's another battery still in there. God on earth, how are you supposed to get that to stop out? It looks like there's another one in there. Okay, so something's sliding out. Oh, okay, so there's like a... Oh, wow. So it just takes 3 AA's apparently. So I guess they go in this little carrier. So now if we look down in there... I can convince it to focus on that lens. I think that's it. But that's quite amusing. I guess it just takes AA's. I'll give them props for that. It's a hell of a lot better than anything that takes like bizarro, specialized, you know, you will never ever find these batteries on the market, ever batteries. Well, shit. Batteries are still even good. Go frickin' figure, man. I guess it doesn't use that much power. So I probably will now have to reset a bunch of the NV RAM or something. I'll just put them back in. Yep, there's a spring in the back. So here's the little front cover. It looks kind of like a weird fuse case. Fuse cover. So it's just a half-turn bayonet lock. And then the metal cap goes on. Just seems that's about tight. Alright. Let's I unplugged it. Oops. Where are you caught on? Oh, it's caught on a computer. So let's place the lid on there. Let's see what we get now. All the numbers changed. And it's saying power interrupted, which I know. Marine parameters lost. So that's a little annoying. I guess it had the machine parameters. I wish I could have figured out what they were and copied them before I did that. Ah well, I'm dumb. So let's take the cover off this. Well, is there any easy way? I don't see any real documentation. I wish I had a system schematic for this so much, but as far as I can tell, nobody it's not available. I have like the flow chart thing that they produce. Heidenhain makes available, which is better than nothing, but it's a really, really, really bad scan, which doesn't help a lot. Anyways, so it appears the whole casing comes off of this thing. If we look here, see they've got the hole here, so I think this might be floating, or I can just, it's big enough for the connector to fit through is what I'm trying to say. Very bad. Out very much in the way of I'm just bad at words today. Anyways. So that is Durr. So that just goes like that. Oh, that smells like old electronics. Woo, that is strong. Yeah, so this is a fairly straightforward, just a good old-fashioned CRT. Thing. So these two leads here go off to the potentiometers. Here's obviously our HT. There's our magnetic deflection. These are our electron gun connections. This appears to be an additional grounding connection, though we also have these heavy grounds. You can see there's spade lugs here that go down to the circuit board. What I'm interested in here is these capacitors. Because as I said, the problem we have looks a lot like excessive ripple on one of the, like the horizontal deflection isn't working quite properly. It's an interesting heatsink. I don't think anything in here should have too much in the way of high voltage at this point. I've got a, that's a classic cap stuck on it. There's a TR3 device under there. Let's see if I don't really want to. Oh, it's recent enough that it's got a sill pad on it. Yeah. Oh wow. BUX82, and it was held on with hot melt. These normally just kind of, they're not very strongly retained. We've got another. So these are your power transformers. Excuse me, power transistors. These probably drive the flyback because that's the leads for this TO3 device run over here. So this could be some of the horizontal driving things. Got a bunch of, I think those are inductors. They could be capacitors because they've got a positive and negative on it, and I don't think what else is polarized. These down here there are some. Let's see these things. Those are like gas discharge tubes. I don't know why the hell they're in here. It's very strange. But yeah, my suspicion is that one of these axial bypass or power caps are probably roached. It appears I can make this lay flat if I take these two screws out. Find a screwdriver that fits that. Too big. Also too big. Alright, it's all, you can see I took these two screws out which held this retaining nut, and that lets it just fold down nicely. So now, let's power it up again, make sure I haven't ruined anything. So here's the documentation on this thing. You can see the wonderful high scan quality going on here. But so we've got differential inputs, so on and so forth. Here's the diagram of the board locations, which I was reading off of earlier. But what's interesting to me is this page here. So this is obviously the backplane PCB. So it looks like if I pull the bottom off, I may be able to probe these points directly. So I think I will seek to do that next. Because you can see here that, so we've got our input, here's the input switching, big power supply transformer, and then there are all your output taps, and they route right to those pins with wires. So, so there's our analog board. Incidentally, the analog board appears to have a single 12-bit DAC and free sample and holds, which I think is because DACs were too expensive to have one per channel, and the analog stuff was cheaper. You can also see this is mostly in German. So that's obviously the front panel interface boards with all the ribbon cables. Yeah, they, let's see, where was it? Where did they mention? Somewhere on here they mention, oops. Yeah, so it's link for the systems with constant incremental Heidenhain rotary encoder. I can see the encoders on this. I'm pretty certain they're actually it actually uses rotary encoders, which is nice. Somewhere in here they mention that it uses typical differential signaling. Blah blah blah. Not the greatest PDF reader. Oh yeah, here we are. So these are apparently all of the rails the system uses or has generated internally. So I certainly think it has enough of them. It wouldn't surprise me if that 4.2 volts is used to run the heater, the filament on the CRT. It's the only real use I can see for AC in this thing. Yeah, so it's got a TMS 990. The display board has a P8085, which is kind of funny. Interface board has, yeah, here we are, count impulse, an electronic hand wheel. VDU board, TMS 9927. Okay, so that 9927 device is the that's the video output apparently. Oh, and it's got a character memory. Interesting. So that's promising. Yeah, okay, so there's the 5-fold EXE with differential line receivers with hysteresis and cable termination in accordance with EIA RS422, which is nice. That means it's 422. Reference impulse decoding, I can only assume is home position. Supervision, I guess, means it detects when something locks up. I don't know. The electronic hand wheel is the manual crank. I'm not too sure what some of this stuff is. But yeah, you can see down here, so it's got an analog converter DAC, it's a reference source, and a reference voltage amplifier. So it's a current output DAC, which is interesting. And then a sample and hold for the 3 analog outputs. So the servo controls in this system are, let me see if I can find the documentation for that. They're plus or minus 10 volt servo controls, which is an extremely common system. So it seems like most of the documentation for figuring out failures involves loading their test code, which is annoying because apparently whatever's failed isn't tested. So terminal test board stuff. Yeah, see, like all these burn-in test programs and junk. So I guess this is a yeah, so 0 degrees and 90 degrees. RI I is going to be probably index LO, I would assume is power. So it looks like the idea here is you gang all of the position encoders together. So that's the data testing thing. That it's got a serial port on it. Ooh, that's interesting. One thing I could actually do that might be a good idea is I have an EEPROM reader. I could dump all the proms in this thing. You know, they've got flow charts for how to run it, assuming you can read in test program, but I don't have any of their test programs, which is annoying. This is nice, where this is the so incidentally, that board with all the relays is indeed a 24 in, 24 out board. We can see here, this is really nice actually, because from this, even if we decide to replace the controller, I know where all these pins went, so I can figure out what everything is. Yeah, so, you know, blah, 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 blah. So one of the things my friend and I have been discussing is the potential of replacing the controller in the system with a, you know, something more modern and recent that we have some experience with. We've both done a lot of work with Galil motion control hardware, and they're generally fairly inexpensive on eBay, and it basically talks the same comms. So that's definitely a potential option that we've been considering. Anyways, let's where did I put the 5 screws in? So I push the 5 little screws for the top panel. I put them somewhere. So I just flipped this on its side and something rattled around in there. Alright, so this point it's loose. And just have those 2 big cables tying it in. Oh wow, look at that, isn't that nicely engineered? As usual, this thing's really, really nice to build. Since this connector is not really going anywhere, I'm going to pull that off. So all of these have these, like it's got this really nice, like, grabby flap on it that you can use to just pull it out of the connector more easily. It's worth noting that these are 3 pins deep, which is kind of esoteric. Yeah, anyways, this is described as a mixture of linear and switching, which I think looks apt, all told. We've got that, and then that's pretty funny. There's a TO3-TO220 heatsink, and it's got a TO3 in it. So I'm going to plug the monitor in. This goes right there because I need its load there while I'm probing around looking for things that have too much ripple. I'm just thinking I kind of want to throw 2 of the screws in the side panel of this thing just to keep it in place. One's just enough. So, looks like we have a whole bunch of big chunky caps. Obviously got this fairly heavy power harness. So I don't know if this is the problem, but it is certainly a problem. So you see that? At one point that was a capacitor. And this was like that. It's not anymore. So yeah, this was what was rattling around. Well, there's your problem. So, oh, that's interesting. I hadn't seen kind of these rubber seal on the bottom caps like that blow to the point where they just fired their cover off. Like that must have left with some decent amount of kinetic force. Pew! So yeah, I'm not totally certain how to read this. It says it's 1000/116, I think, which I assume means it's 16 volts, but I'll probably ask on a forum just to be sure I'm not totally being a fruitcake. And then when I'm doing that, there's actually 3 other caps from what I assume are the same line, and I'll probably replace those too. The thing worth noting is I'm not sure if this is the problem or the source or just a symptom. There may be another problem somewhere which just caused this cap to be over voltage, which caused it to blow like it did. It's interesting that the system seems to kind of still work. Yeah, so in any event, I might just recap this whole thing. Yeah, see, these are 2.2 millifarads, or well, 220 microfarads, 40 volts. These I think are 47/63. These are 1000-16. This is 1000-25. So yeah, I think that's 10-6. Yeah, these are oddball looking caps. Anyways, that's a fairly straightforward fix. Oi, I think I might even have one. Here's the board. This is fairly interesting. It looks like this might have actually been repaired once before. I'm not too sure, but there's definitely flux marks in a few places here. And only a few places, which is kind of intriguing. Anyways, I'd like to see if I can get this off without damaging the capacitor, because I'm kind of curious. I want to see if I kind of want to try and measure the capacitance. I've got one of those shitty little eBay special single micro cap meter things that runs on like an 18 mega 8, and I'd be curious to see if I could potentially convince it to. It's warming up. See if I could measure the capacitance that it actually has. It's right on the edge of normal. This thing takes a long time to heat up. So this is obviously a desoldering gun. Also, fart noise maker. But that's kind of an incidental feature. I don't think it was originally in the design spec. Where is my box of spare capacitors? I don't know where I put them. I need to organize so badly, and I don't. So I dug up some. It's a 1500 mic 25 volt cap. It's actually smaller, which is kind of funny. Problem is I don't know which way positive goes because the pads are both round. Yeah, the pads are both round, and the polarity indication was fired off of the board when the capacitor failed. So I'm very much guessing about which way this has to go, just based on following some traces and looking like it goes that way. If this is a negative rail, I'm gonna probably be wrong, and we might get fireworks. But I don't think it is. Well, I guess it could be. Unfortunately, there's no other capacitors. Well, actually, that's something I'll look for in a second. Alright, that's on. Let's just clean that down and clean that down. So So we run down to there. So the white lead, yeah, actually this is helpful. So if we trace this lead out, we come off this side of this capacitor, go through this inductor, through here, through this bridge, and then to this white lead, and it looks like that actually goes to the positive terminal of that capacitor. Let me actually let me validate that. So I am in beep mode. Right. Yep. I'll put one lead here and one lead here. Yep, and that should also be there. Okay, so actually that would be interesting. Let's put one lead here. Okay, I'm on the right way. So what I just determined is that effectively, let me flip this back over. So what we have here is a pi filter. We've got the capacitor, a series inductor, and then another capacitor. So that's obviously just trying to keep noise out of something or something along those lines. But that means that this capacitor and that capacitor are functionally in parallel. And the fact that they're both oriented the same way, obviously positives here and it wires to the positive here, means that I can be relatively confident that unless this capacitor labeling is backwards, in which case I'm going to have to go find somebody from Germany and smack the shit out of them because this is German made. I think it's a safe assumption to bet that the cap's in the right way. So just gonna put those two screws in because again I am planning on recapping the rest of this if this fixes the problem. So now I have to just kind of angle it up, and that big thing goes in there. And what we do now is we unhook that, lean back, and see what happens. So, bada boom, bitches! I is muchly happy. So I'm gonna go in and recap the rest of it. Sweet! So if you're curious why I'm not replacing all the capacitors, that's actually principally because I don't have enough caps on hand. I'm replacing all of the ones of the same series, but I don't have a lot of capacitors on hand, and I don't really want to just go replacing them all with bigger values. I'd rather actually make sure I match the existing value just as a, I'm being overcautious, but what the hell measure. So, yeah. Anyways. So I guess the question now is, obviously I have to re-enter a bunch of the machine stuff. Okay, so if you set them correctly, it actually does idiot check. That's cool. So I have to dig this up. The CNC zone forms have some of the machine parameter stuff for these, so I'll just have to deal with that. But it looks like it's more or less working now, which is cool. So yeah, I guess that's it still makes the most god-awful noises. But I think it's mostly functional now. I have to get the rest of the system working. Hey, it's back on my desk. So, why? Because it's still having issues, unfortunately. Good news is, it turns out that the German manual has power supply voltages in it, so I actually can now figure out what all the internal power supply rails are and actually test them properly. I suspect if one of the caps shat itself, some of the other ones might have, so I think we're basically going to go for a full-on recap at this point, just replace all the capacitors, and we'll go through it. So here's the fun thing. This is the Serviceanleitung TNC 145. This is the German service manual. And the thing that's important here, so this went right past it, is this. Pin out to the power supply. So we can figure out what's going on. So 21 volts. A lot of these aren't connected. Obviously this is connected with 10 pins. One of the things that had me confused, this actually answers, is there's only one ground. See the 0 volts? Which is very strange. I would have expected there to be many more. I would have, I mean, considering they have all these rails, I'd expect maybe 2 or 3 ground pins to return all that current. But I guess, yeah, most of them aren't even balanced. Go figure. Anyways. So, we'll go there. So we can look at it. So, let's get some more light on the subject. So, into the documentation. So, 23 and 24. So, 28, 27, 26, 25, 24, and 23. So, the black lead is in fact ground, which is at least nice of them. So, we will put on there. And then we power it up. I'm looking at the display, which is right back here. Power interrupted. So, 25, 26 should be 11.2 plus minus 0.25. Which is this right there. 1.12. So that is correct. So this last one over here, I believe, should be 0 volts. That's shield. Bill Sherm, don't look up at shield. So 21 and 22, which is right here, should be 5. 5.15 is supposed to be 5.16 plus or minus 0.08. Right spot on. 20 is supposed to be negative 14. Negative 14.9 plus or minus 0.6. 15.9. So that's a bit off, but that could be because it's unloaded right now. Next one's 45.2 plus or minus 1.5. 56. That's very high, but again, it's not loaded. I think when the encoders are on here, it brings the power supply down a lot, which is annoying. Next one's 21.6. 31. 12.0. Well, actually, let's see. Yeah, so that brown. 12.02. So 16 is 15, which should be this pin here. 16. 15 and 14 are the AC pins, which are this pin. Yeah, so 1.9 and that pin. That's actually low. It's supposed to be 4.2 volts. High spindling. So, it could be floating. 3.94 is close enough. So DC coefficient 0. I think it's floating relative to, which is why I'm getting a strange reading. And then 13 is signal nets, which I'm pretty sure is mains present with that translation. And that is this pin here. 4.69 volts. So it looks like all the rails are about right. It feels like it's getting quite warm. Oh, not really. So I suspect I'm going to have to replace the rest of these capacitors because that's probably my problem. Anyways. Engage the oscilloscope! I guess I should say kind of preemptively, if you're wondering what percentage of this is going to be me yelling German terms in a horrible Dalek impression with a bad accent, the answer is yes, and I'm sorry. No, I'm not. So, we are powering up. It is alive. And we are currently on the plus 11.2 volt rail. So let's turn off AC. Oops. (11.1 plus F). So it's pretty noisy. I'm not too impressed, but I wonder how much of that is just ambient field junk. Alright, so then this is the ground. Yeah, okay, so if I ground the scope probe, I get all that. So it's mostly just coupling. It's not too impressive. Is my ground connection over again? Yeah, it seems like it's fine. Yeah, let's it's probably a more accurate measure. That's a 20 megahertz band limit on. So we have ground. So this is the plus 5 volts. Hello. So that is 200 and roughly 250. Also, what's our period? That's fairly interesting. I'm just wiggling these probes around and my high frequency stuff is coming and going. Oops. So 1, 2, 3, 4, 5. 5 divisions at 100 microseconds. That's roughly 500 microseconds. It's about 20 kilohertz. A little lower. Kind of matches the horrible noise this thing makes. That's 5 volts. This is our negative 14.9, which matches the fact that it comes up from the bottom. Yeah, that makes sense. Back in auto mode. So that's an interesting waveform. So that could be one of our problems. That's the 45 volts with a whole lot of garbage on it. So that is 19. Yeah, okay, this is pin 18. That's plus 21.6. So we have some interesting current draw waveforms going on, definitely. So 19, 18. So that's, excuse me, 17. That's the plus 12 volts. Should be the plus 15. Got some ripple there. (15) and 14 are my AC. 13 is my sine. A whole bunch of ripple there too. There's our 60 hertz. So yeah, I'm just going to assume, I think most of the caps in this thing are probably just totally shite. One thing I can probably do is, because this is actually floating, is if I ground that terminal, which just seems to be fine. That's the ripple on our main AC filter cap. Let's see. I want to be slope triggered. Oh. There we go. So that's about what we'd expect. That's a, actually, let's see if I can convince the counter its frequency. 120 hertz, exactly what we'd expect with a square wave rectified mains. So that's a peak to peak 1.2 volts. That's not terrible. On what's our, so I think there's two different rails here. maybe not. But wait, I was going to look at what our overall peak-to-peak DC value was. I'll go back to the manual trigger. $24 volts or so. Measure, clear, 2, 1, 2, 4, okay. The average, 21.5 volts. Wow. And my signal is specified as 21 volts, which is interesting. What the fuck is that? That's some weird AC sine wave, man. So we have 1, 2, 3, 4, and it's these 4 pins. It's these 4 pins here. And the middle 2 not have anything on them. Whereas the outer 2, I've got that on them. I mean, I'm running on an isolation transformer, but I don't think it does that to the AC mains. And this is definitely just, it goes right into this transformer here. So, it's just totally flat topped. Weird. And there's only 2 rectifier diodes on here, so I think it's, you know, center tap, half wave rectified on each half, and then there's 8 anti-phase, so you get full wave rectification, which is 2 diodes. Use more copper, but your copper losses are just as terrible, actually. That's weird. That gets a little bit warm. And that one gets really warm. I'm still convinced it's a, actually, that would interest me, which is, there are these very large bus bars all over the place here. Let's see what's on them. So, actually, I'm not sure if they're split bars or not. Well, there's a whole lot of garbage. Right now, acquire depth. Let's turn this down to up here. So that's got to be our main switching waveform. Which is 20 kilohertz right on the button. But the weird thing here is that if you look at where I'm measuring on the circuit board, let's see if I can get the camera off my hand. So I'm currently measuring on one of the bus bars. So I'm measuring right on that bus bar, and I've got this. Oh, I know what's going on. That's one of the main capacitor rails. Because if we follow this over, it goes to over there. And actually, I think, I'm not too sure. Anyways, let's keep poking around. So we've got this big DC voltage with an AC modulation on it. Because remember, this was it's average of about 19 volts with a peak to peak of measure statistic off. It's a peak to peak of 6 volts on a 19 volt rail. The other side here is, okay, that seems to be ground. Let's look at the other one. So here's the top side of this. Average of 21 volts, peak to peak 5 volts. Let's turn on a VRMS. Oops. Maybe I can hit the right button. Durr. So, yeah, it's an RMS of about 300 millivolts. Whereas this, the thing with the square waves on it, which should be, that's an RMS of 2 volts. And I just learned something interesting. These are, oh, that pin I'm probing, that ain't ground, or that ain't the bus bar. I'm poking the wrong point. Yeah, so that's high. That's ground. So that bus bar must be VCC of some sort. That's also VCC. I can't get to the one in the middle. But if I go over and I measure this point, yeah, so that's just our 60 hertz modulation. That's interesting. Interrupted duty power supply. I guess whatever it's supplying is currently not very heavily loaded. So there's the one I probably hear. I think there's a bunch of post DC to DCs after this. Problem is, I don't know who goes where. Let's see what's there. That's an output filter. So doing like 63 volts. This is like 25 volts. I'm just going to just recap a bunch of this, because I am not sure where the problem's coming from. Anyways, do some high-res board pictures. So I'm basically just noting all the caps I'm going to have to replace and their pin spacing so that I can order the proper parts. I'm basically going to just recap the whole thing because these are weird capacitors. And then if that doesn't fix it, fuck. So. Connector just hit me in the face. So that now goes like that, yeah. So, yeah, actually, that's interesting looking. So, is it just me or does that look like that's leaking to you? This one too. I wonder if this was run like in a very hot environment. So, let's see, this connects, yep. As does that, and this other one down here. Last thing is this ground connection. Yeah, a bunch of these caps look like they're having a bit of a breakdown. So, let's, yeah, some of these look like they're kind of bulgy and oozing. Some of these look like they're kind of bulgy and oozing. I think we'll do a full-on recap of this too. Anyways, so, Yeah, so these caps, it looks like they're like, it's a Bakelite case, and you can see it looks pretty well done to me. Looks like it's been seeping something, because if we look over here, you know, these two seem fine. That one doesn't. So I think the electrolyte might have been evaporating out of these. Something like that. The board is also a very dark color. I don't know if that's just a solder mass difference or what's going on. You can see some little patches down there. There's a couple more caps that are all not too hot looking. It's an old diode. Old parts. That's fairly interesting. It looks like we have 3 spark gaps in here. I don't know what they're for. There's another cap down there. More electrolytics. Some old style diodes. More caps. There's some interesting inductor types. Another very unhappy capacitor. The one single IC in the entire thing. Anyways, correction, there's 2 ICs. There's one under this big heatsink here, but I'm not going to take that off. We also have this, which is a BU-X82. A couple high-power transistors, I would assume. Anyways, so moving on. So I've got replacement parts on order for all of the caps here. What's interesting to me though is that I'm 90% sure that this big cap here is the, I think that's the 5 volt. No, it's not, because these are 16 volts. So I think that's one of the big relevant regulator caps. So I'm going to try just replacing that now. Because I have a part that'll work there. I don't have any caps. These are 25 volt caps, and I think the biggest highest voltage caps I have are like 35. So all the 63 volt parts are going to have to wait on the order coming in. Also, all the shit going on the monitor.